Hello everyone, and welcome back to the Fluctus Channel. During a mission, a continuous supply line is critically important for sustained operations. All helicopters and fixed-wing aircraft shuttle back and forth between the forward arming and refueling point, FARP, during a mission for fuel and ordnance. Transporting jet fuel safely and rapidly to these congested zones is never a simple task. The U.S. military employs clever and highly coordinated methods to move vast quantities of flammable fuel across borders. When considered together, U.S. military consumes nearly 270,000 barrels of fuel each day. Among them, JP-8, or Jet Propellant 8, is the most widely used type of fuel that powers a broad range of vehicles, from fighter aircraft to tankers and other ground support equipment. Most of this fuel reaches its end users through fuel lines. While a certain amount must travel toward the forward arming and refueling points to support battle areas. Due to terrain conditions and other limiting factors, transporting fuel to these locations can only be accomplished by air as a sling load. A fuel blivet, a collapsible fabric container, simplifies this task, as it can be sling loaded by helicopters and delivered to any austere location. A blivet has two closure plates on each end, providing the required structural strength. One closer plate houses a fuel coupling for filling and draining. Each closer plate includes a swivel ring fitted with two anchor shackles. Blivets can be rigged as a dual or triple setup using chains and sling legs. In a triple blivet arrangement, when viewed from one side, the chain runs through the shackles of the first two blivets, forming a triangular shape, and it connects to a sling leg through a grab hook assembly. The same attachment appears on the opposite side as well. For the remaining single blivet, the chain is routed through one shackle and connected to another sling leg via a grab hook. All sling legs attach to an apex fitting that bears the entire load and connects to the helicopter's cargo hook. Sling legs are numbered, as they must follow a specific sequence when inserted into the apex fitting to ensure correct load distribution. In situations where more fuel must be transported over long distances, the sling load method is not the best option. Therefore, U.S. airmen rely on the Aerial Bulk Fuel Delivery System, or ABFDS, which can carry a massive 9,000 gallons of fuel in 3 identical bladder tanks. These bladder tanks are mounted on modular platforms that can be easily loaded into the cargo bay of the C-17 Globemaster III, transforming the colossal bird into a flying gas station. Once loaded, these bladders receive fuel from trucks through 2 refueling pumps. Regardless of capacity, all fuel bladders are extremely durable. A bladder capable of holding up to 210,000 gallons of fuel has an empty weight of around 4,000 pounds. With that said, rolling out a new bladder is a task where airmen from all units come together. These fuel bladder tanks are often called bulk fuel tank assemblies and play a crucial role in a tactical petroleum terminal. These terminals are invaluable when fixed fuel storage facilities are unavailable. U.S. military can store nearly 1 million gallons of fuel in a tactical petroleum terminal, greatly increasing mission readiness. A filled 210,000-gallon fuel bladder occupies an area of 4,900 square feet, equal to the size of a basketball court. A venting system releases pressure to the outside atmosphere if internal vapor pressure exceeds 10 pounds per square inches. The initial installation of a fuel bladder demands a significant amount of earthwork. Typically, the process begins with cutting the soil to accommodate the tank, followed by constructing tank berms to protect it from foreign object damage. These berms contain the fuel if the tank ruptures due to enemy attack or failure. A bladder tank has a lifespan of 3 to 5 years. Once a tank reaches the end of its service life, it is drained and removed from the pit, and a new bladder is installed in the same location. The tank has 2 dedicated assemblies for filling and discharging, allowing it to be filled while simultaneously supplying fuel to users. Regardless of fuel availability near a battle theater, the extended time aircraft spend refueling gives enemies more opportunity. To reduce refueling time, the U.S. Air Force developed hot pit refueling, which allows an aircraft to be refueled immediately after landing while its engines continue running. This removes the need for post-flight inspections at each landing and enables the same crew to fly consecutive sorties. Typically, fuel trucks are loaded with the correct fuel even before the aircraft lands. During refueling, crew members remain inside the aircraft preparing for the next sortie. In March 2022, the Air Force conducted a hot pit refueling operation with the KC-135, stating that this method reduces refueling time by 69%, additionally giving. As the largest fuel consumer in the Department of Defense, the U.S. Air Force uses around 2 billion gallons of jet fuel annually. This enormous fuel volume flows through thousands of aircraft, ground vehicles, and other ground support equipment. This demanding task is carried out by fuel distribution operators in the U.S. Air Force, who work around the clock to fuel missions. While bladder tanks are widely used for fuel storage in remote areas, Air Force bases rely on above-ground storage tanks, AST, and underground storage tanks, UST, for bulk fuel storage. These tanks are permanent installations with a service life of approximately 20 years. U.S. airmen are responsible for performing regular integrity inspections to detect flaws developing in bulk fuel storage systems. In addition to visual inspections, these tanks undergo non-destructive tests, NDT, to identify hidden issues in the tank's metallic structure. When a flaw is detected, appropriate repairs may be conducted, or the tank may be demolished if the damage is beyond repair. Before demolition, the tank is isolated from the active fuel system, and all sediments from the tank bottom are removed and treated accordingly. Despite the large volume of fuel used daily, every batch of fuel must be examined for proper grade and quality. Fuel specialists perform the demanding task of quality control by testing fuel samples in laboratories. These samples undergo tests to detect contaminants such as water, rust, and sediments. No solid particles are permitted in fuel. Beyond contamination tests, laboratory technicians evaluate the thermal properties of fuel samples. Proper thermal properties ensure fuel ignites at the correct temperature and releases the required energy. Several inhibitors are added to enhance fuel quality. Fuel System Icing Inhibitor, FSII, is added to prevent ice crystal formation from water within jet fuel. The fizzy test confirms that fuel contains the required amount of icing inhibitor to prevent freezing at high altitudes. Even after these tests are completed, the fuel quality assurance process does not end here. Forward Arming and Refueling Points, or FARPs, are temporary logistics sites that extend the operational reach of aviation units. Positioned near the front line, they allow helicopters and tactical aircraft to rapidly refuel, rearm, and return to combat. FARPs are mobile and can be established on austere terrain using fuel bladders, self-propelled pumps, and security perimeters. Speed, dispersion, and camouflage help reduce vulnerability. Typical teams include maintenance personnel, fuel handlers, ammunition specialists, and security forces. By reducing transit times, FARPs increase sortie rates and operational tempo, giving commanders flexible options during maneuver and expeditionary operations. They effectively support modern joint operations. U.S. Marine bulk fuel storage in remote or wilderness areas depends on rugged, transportable systems to sustain operations. Crews establish temporary fuel farms using palletized tanks, fuel bladders, pumps, filters, and containment berms. Setup prioritizes safety, including grounding, spill prevention, and separation from living and ammunition areas. Installing open-air fuel bladders begins with firm, graded ground, anchoring points, and protective mats. Bladders are connected using hoses, fittings, and filtration systems, then tested for leaks before filling. Trained fuel handlers manage inventory. Security teams safeguard the site, and routine inspections ensure fuel cleanliness, system readiness, and environmental protection. In forward areas, U.S. Marines frequently face the challenge of keeping helicopters and vehicles fueled far from established bases. To address this, they operate long-distance fuel lines directly from forward arming and refueling points, or FARPs, to the front lines. Crews unspool reinforced hoses across rugged terrain, linking them with quick couplings, inline filters, and pressure valves. Portable pumps sustain fuel flow, while grounding and bonding prevent static discharge. Teams continuously inspect the lines, monitor for leaks, and sample fuel for contamination. Security patrols protect the route from tampering or damage. Through precise coordination and relentless maintenance, Marine fuel specialists keep the lifeblood of combat operations flowing, ensuring aircraft and vehicles remain fueled, ready, and mission-capable wherever the fight leads them. In the end, none of these missions succeed without fuel arriving at the point of need at precisely the right time. From sling-loaded blivets suspended beneath helicopters, to massive bladder farms supporting entire air campaigns, and from flying gas stations in the sky to hot pit refueling on the ground, fuel distribution remains the invisible force that keeps combat power moving forward. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.